Um, you'll probably want to open up your doc in the new tab. I'll get my slide open here. All right, so it's not too hard a math. If you can count, you'll be good. You know, count to like up to 8 at the highest. And if you can multiply within 10, you know, like 2 times 8 or 2 times 3 or 3 times 5, if you can find the least common multiple, that's also helpful skill. All right, so remember our recent lesson, 2.6, day 1, law of conservation of mass. In your own words, write the law of conservation of mass. And you might be thinking, I don't remember for sure. Well, here is it. This is the definition I got. So in any physical or chemical change, matter is neither created nor destroyed. Matter can be changed from one form to another. So you can write the definition in your own words or shorten it, abbreviate it. All right, everybody got done with this? All right, the objective is to learn how to balance chemical equations. Delaware/Forma. I'm going to do some notes about the equations in the practice. You're going to be working around. There's a wrap up and an optional extension. All right, we watched this video, maybe, hopefully you watched the video last time. He showed how to balance chemical equations. So that's really cool. In this slide, I've got this slide, we've got tons and tons and tons of videos. So if you go home over the weekend, Saturday morning, you want to wake up early and get extra practice with balancing chemical equations. If you want to watch a video of me doing it, instead of watching a cartoons or YouTube or something Saturday morning, then this would be a great place to go. If you look at what did you say? You want to do that?
No, I said I was excited after this.
Oh, that's neat. And if you look at your book, it's on page 176, 177 here. All right, I'll notice 4 main steps to balancing chemical equations. Step 1, write the equation. Luckily for you all, in 8th grade science, most of the equations are written for you. Don't worry about that too much. Step 2, count the atoms. You actually did a little practice counting atoms on the previous lesson, the law of conservation of mass, but that's pretty easy. You know, having many, the highest number is like 8. Use coefficients to balance atoms. This is probably the hardest part. Raise your hand if you've ever heard the word coefficient before. Most people have. Good. I think the advanced science class, they have to, you're scheduled to do what you got your math class. So coefficients together, like the number before the variable, so you multiply by it, really similar in science class. And then last, and definitely least, to look back and check. Always, 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 students in elementary, middle, high school, college, never, ever look back and check. Maybe like actually Josh. But everybody else does look back and check. And it's actually something you almost like have to do every single time you put the coefficient in, is you check to see if it's balanced or not. So that's the 4 steps. All right. Balanced chemical equations. The principle of conservation of mass means the total number of atoms of each element in the reactants must equal the total number of atoms of each element in the products. To be accurate, a chemical equation must show the same number of atoms of each element on both sides of the equation. Chemists say an equation is balanced when the conservation of mass is correctly shown. And that's what we're going to do today, balanced chemical equation. So step 1, write the equation. Again, this is the step you won't really do too much. Suppose you want to write about the equation for the reaction between oxygen that forms water. You see down here, hydrogen plus oxygen. This arrow, the word, you don't say equals, you say yield water. The place the reactants H2 and O2 on the left side of the arrow, separated by a plus sign. Then write the product H2O on the right side. If you're having trouble writing that, sorry, this is the way it's set up. If you select like the underscore, type in the letter, and select the little underscore below it, check the number, and select the other underscore, it should make it work. But make sure you have capital H, capital 2, wait, no, lowercase 2, wait, what? I don't think it's especially a capital number. Should they be capital numbers? They should be capital numbers. Anyway, to have these capitalized, again, that's the correct way to write them. If you're having trouble getting the two be small or short, it's called subscript, you can highlight it, select it, then hold that control and push period. That'll make it subscript. This is not all that important. To be honest, so if you're having trouble with this, okay, just write it out. H2O2, H2O. All right. Step 2, count the atoms. This is what y'all practiced in the previous lesson about equations. So you're going to count the number of each element on each side of the equation. Recall that a subscript tells you the ratio of elements in a compound. So again, subscript is a little number little. So H2 is going to be 2 hydrogen atoms. O2 is going to be 2 hydrogen atoms. On the right side of the equation, there's 2 hydrogen and only 1 oxygen. That's what we got by times 2. So we count 1, 2, 2 hydrogen atoms. Oxygen, 1, 2, 2 oxygen atoms. And then we're going to count separately on the right side of the equation after the yield symbol. Hydrogen atoms. How many hydrogen atoms are there on the right side of the equation? Yeah, and oxygen? Right. Perfect. Easy peasy. This is how the harder it is. Oh wait, then step 3 comes in. All right, so after counting, you find there's 2 atoms of oxygen in the reactants, only 1 atom of oxygen in the products. How can the number of oxygen atoms on both sides of the equation be made equal? You cannot change the formula for water to H2O2 because H2O2 is the formula for hydrogen peroxide, a completely different compound. So how can you show that mass is conserved? So before we move on again, next step, isn't this like the most amazing thing? Wait for it. Bam. I know.
So smoothly.
I know. Pretty magical. Anywho, so it's unbalanced right now because on the left side of the equation, there's 2 oxygen. On the right, there's 1. So we have to add coefficients to balance it. That's what the next step is. So step 3, use coefficients to balance the atoms. To balance equations, use coefficients. A coefficient is a number placed in front of a chemical formula in an equation. It tells you the amount of a reaction or a product that takes part in a reaction. The coefficient applies to every atom in the formula it is in front of it. If the coefficient is 1, you do not need to write that. Balance the number of oxygen atoms by changing the coefficient of H2O to 2, and again, count the number of atoms on each side of the equation. So that's what we're going to do over here. We're going to add a 2 in front of H2O2. And you can see before there was just 1 water molecule. Now there's 2 water molecules. That's what the coefficient is doing. It's just multiplying each one times the coefficient. All right, so we put the coefficient in, and we count the atoms again. On the left side, we have 2 hydrogen atoms. On the left side, we have 2 oxygen atoms. That didn't change, I said it before. But now on the right side, numbers are changing a little bit. How many hydrogen atoms now do we have on the right side of the equation? Yeah, exactly. And how many oxygen atoms? So that's great. Now oxygen is balanced. But hydrogen became unbalanced. So that kind of thing. not too bad, because we can still have more coefficients. May I have any guesses as to what the next coefficient will be to bounce off even more? Word up with the 2. Yeah, exactly. So, that's the position number 2 here. That'll make 4 of these hydrogen atoms. That'll completely balance it off. So let's look at the next step here. So balancing the oxygen atoms unbalances the number of hydrogen atoms. There are about 2 hydrogen atoms in the reactant and 4 in the product side. How can you balance the hydrogen? Just like she said, change the coefficient of H2 to 2 to count the atoms again. And this is the board step is done for you. And the thing is now out.
Whoops, yeah.
Yeah. That's done, yeah. I don't know why there's a bell in the class, but period 3 doesn't have a bell at the end of class. Doesn't make any sense. Oh, what are you gonna do? Wait.
Either a Wednesday bell or like.
Well, I think what it is a different class going to lunch now.
So why they don't go for their lunch in last year?
Exactly. That's exactly.
Why are they so special?
Yeah. Oh, let's keep going. All right. So step 4, again, the most unused step in history is look back and check your work. What you guys are gonna have to do. So how? Is the number of atoms of each element in the reactants equal to the number of atoms of each element in the products? If so, mass is conserved and the equation is balanced. The balanced equation tells you 2 hydrogen molecules react with 1 oxygen molecule to yield 2 water molecules. And here it is written down. 2H2 plus O2 yields 2H2O. All right, so this is a great way to do it, but we're not always going to have little pictures and images to go along with it. So this video shows us a really good, efficient way to balance chemical equations with just writing numbers and letters and anything you can type on your keyboard.
How to balance chemical equations in 5 easy steps.
You got a smooth
Step
voice.
1, count the atoms on each side of the equation. Let's count each type of atom. Sulfur, I have 8. Oxygen, I have 2. On the product side, sulfur, I have 1. And oxygen, I have 2. Note that if there's nothing after an element, we assume that to be 1. And that's it. We're done with the first step. Smooth. The big rule for balancing equations is that we can only change the coefficients. Those are the numbers in front of the atoms. The numbers after the atoms, the subscripts, cannot be changed. So let's balance this equation by changing the coefficients. If there's no coefficient written, we assume that it's 1. So right now there's a 1 in front of each of these terms. We can see that we have 2 oxygens on each side of the equation. So the oxygens are fine, but the sulfur atoms, we have 8 on the left side, the reactants, and only 1 on the right. Well, to fix that, I can change the coefficient in front of the sulfur on the right and make that an 8. So if I put an 8 here, that means 8 times the 1 sulfur. That'll give me 8 sulfurs. And now my sulfurs on both sides are 8. But this 8 here is also times the 2 oxygens. And that gives me 16 oxygens. So I fixed the sulfurs, but the oxygens are balanced. I can change the coefficient here, though, to 8, because 8 times 2 equals 16. So now I have 8 sulfurs on each side, and I have 16 oxygens on each side of the equation. This equation is balanced. Step 3, so you don't forget, only change the coefficients. Let's try another problem. So,
All right, pause there for now. You can finish watching that if you want. Here's another example of how to do it. This one doesn't really make any sense to me. I'm not even going to bother looking at it. But if you don't understand any other way, maybe this will make sense. It's what the book suggests. We're going to practice a few together, and these are practice questions they have us have in the book. You can have every single step shown for you with a few clicks on the slide. What I'm going to do is I'm going to pull up the actual document here and do it with you. So you can type it in with me as you go.
Exactly.
Why does it be 3 vowels in one period?
Right, I know, right? All right, that might be seventh grade. All right, so KClO3, potassium, chlorine, and oxygen, yields potassium, chlorine, and oxygen. So the first step is write the equation. The equation's written for you. Good. Second step is count the atoms. To help us count the atoms, we need to keep track of what elements are on each side of the equation. They are the same on both sides, K, Cl, and O, and K, Cl, and O. So I did this for you, and I just really easily selected these, copy, went over here, and pasted it one before, just because they're going to be the same, and you want to be in the same order. K first, Cl second, O third. It doesn't matter what order they're in as long as they are the same. All right, so on the left side, on the reactant side, how many potassium, how many K are there? 1. How many chlorine are there? How many oxygen? All right, so literally label these like that. So we're counting the atoms. On the left side, we're already done. On the right side, now we need to count. How many potassium on the right? How many chlorine on the right? How many oxygen on the right? 2. All right, so potassium's balanced, good. Chlorine's balanced, good. But oxygen is not balanced. There's 3 on the left and 2 on the right. We need to find a good number that both 2 and 3 go into, and we can multiply 2 times and 3 times to get the same. So somebody said 6. All right, so somehow on the right side, we multiply 2 times something to get 6, and 3 times something to get 6. Because 6 is a good even number. What Carter did is he found the least common multiple. The least common multiple of 2 and 3 is 6. So on the right side here, I'm going to have to multiply that times what? 3 to equal 6. So what I'm doing here is I'm keeping track every single step. So this times 3, really what I'm saying is there a coefficient of 3 in front of the oxygen. So type in the coefficient of 3 in front of oxygen. And down here, take your 2 existing oxygens, multiply that times 3, and that gives you 6. So now that's your new updated number of oxygen molecules on the right side of the equation. Now to match it on this side, we'll have to multiply 3 times to get 6 oxygen. 2. So I'm going to put my 2 coefficient here. And that's going to fix oxygen, but it's going to really mess up potassium and chlorine. We'll fix those later, so don't worry. But let's multiply the oxygen first. So I did 2 is a coefficient, so 3 times 2. And for the times, you can type in the number x, or the letter x, equals 6. But you also have to multiply potassium times 2 and chlorine times 2. So 1 chlorine times coefficient of 2 equals 2, and 1 potassium times the coefficient of 2 also equals 2. So it's backwards. All right, so I multiplied 2 times potassium, 2 times chlorine, and 2 times 3 oxygen. That's done. Now I go back and check, are these balanced? Well, oxygen is, but potassium and chlorine are not. How can I fix the potassium and the chlorine on the right side of the equation? What coefficient, yeah? Yeah, exactly. If I put the coefficient of 2, that will make it so I multiply both of these times 2. And guess what? That balances off. All right, if you're looking at this and you're like, Mr. H, that looks really ugly with all these extra underscores, feel free to delete them. So extra. Also, sometimes you only have to put in 1 coefficient and it'll be balanced. So I had to do 3 different ones, but sometimes it's only 1. Sometimes it's 2. Sometimes you write a coefficient, then you have to change it later to fix it again. Okay? All right, you guys ready to do another one together? Good. I took that as a yes. I have to undo this so it's ready for the next class. All right, next one down, sodium, bromine, and chlorine. All right, on the left side of the equation, how many sodium are there? Bromine, chlorine. On the right side, sodium, bromine, chlorine. Right, and look, so these are in different order, so you have to be extra careful. Sodium was first, then bromine and chlorine, but over here, sodium, chlorine, bromine. So just make sure you're being careful. All right, is this balanced? Sodium is, bromine is not. So let's balance bromine first. How can I balance bromine? There's one on the left and two on the right. Where am I going to put the two? In front of this one here, right? All right, so this will make us multiply sodium times 2 and bromine times 2. All right, that does balance bromine. That's awesome. But sodium is now not balanced. All right, so in front of NaCl here, we put the coefficient of 2. And that multiplies sodium times 2 and chlorine times 2. All right, so sodium's balanced, bromine's balanced, and chlorine is balanced. Can you add any more coefficients or anything? No, we're done. But to make it look nice and pretty, y'all can delete the extra underscore. You might be thinking, well, Mr. H, why is there an extra underscore for the bromine here? We didn't even use it. I'll put that in there just in case. All right. Let's do another one together. Actually, do this one on your own, and then we'll talk about it in just a second. Number 3. So it's 12:03 now. 12:05, we'll talk about number 3. All right. Does any volunteer want to walk me through question 3? Really brave soul. Go ahead. Okay. All right. Then what? Right here. So is that the first one you did? Is that the first coefficient you put in there? Here. Times 2 here. 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 Oh, cool. So you put coefficient 2 here, multiply these both times 2. Then what? This one? Then what coefficient did you put here? All right, so Na is 2, Cl2, perfect. Good job. All right. So there's a wrap up. Describe the steps in balancing a chemical equation. Well, I don't think I did this quite right. I did want you guys to do several of these questions here. At least 5 5 of them. Okay. There are videos for some of these questions. I think I might go over 1 or 2 more of these in a little bit. I'm going to give you guys a few minutes to work. It's 12:06, maybe like 12:15. I'll go over a couple. Okay, yeah. Look on the schedule. There's 3 in the room. Yeah. Nothing? So you can just sign over there and take a sticker. You don't need the pass or the thing. The stickers are at the bottom of the stack. On the very bottom here, there is a link to an answer key. So after you balance an equation, you're going to check to see if you're correct. This has all of them that are balanced. I don't know why I have 1 here, but I really should have 1s. But there they